Chapter 1, Section 3, Part 3. Addition and subtraction of fractions. When the denominators are the same, fractions are added or subtracted by adding or subtracting the numerators and keeping the same denominator. Okay, there's the English version of that. Here's the algebra version. It says for any two fractions, a over d and b over d, notice that the denominators are the same. If I have a over b plus b over d, a over d, I think I said b, and b over d, you add the numerators, so I'd end up with a plus b all over that denominator that's the same. And the same thing with subtraction. So simple rule, and we've been doing this for quite a while. If you have common or the same denominator, it's pretty easy. You just add the numerators. In this case, you'd get 4 plus 5 over 8, which is 9/8. Okay. Now, it talks about proper fractions and improper and those kinds of things. It really means that the only thing I think you may run into where you want to do mixed numbers in this course is maybe some word problems, but almost all the time I'm not going to take that extra step to convert this to an addition, really. And what you're doing here, I can talk about mixed numbers a little bit. A mixed number is just an addition. 1 and 1/8 is 1 plus 1/8. Well, how would I figure out how to add those? I'd have to get that same denominator of 8. Well, I can write 1 as 8 over 8 plus 1 over 8, and I'd get 9/8. Okay. But usually if you get an improper fraction, in other words, a fraction bigger than 1, I'd leave it that way, and it'll take the answer. Don't take another step or another chance at making an error. Okay. So to follow these rules, to add, I have to have the same denominator. So we're going to work on some techniques of finding common denominators using prime factorization. I did a very good video on basically just on this. How do I find an LCM, least common multiple? So I take the denominators, I want to find the LCM, the least common multiple, or because we're talking about denominators, it would be the least common denominator. And we find out what that is, and then we're going to do some multiplication by that identity again, using some of the other things we talked about, fractions, that the same number over the same number is equal to 1. But first we have to find out what denominator are we going to use if I have an 8 and a 12. Well, we want to use prime factorization, and we want to find the LCM, the least common multiple. So they prime factor 8 and they prime factor 12. They organize these prime factors over the top of each other, and they only represent the commons once. So the 2's are commons, and then I have this extra 3. And what I did with the Venn diagramming in the other video that I did really does this too. And then I end up with, I just multiply what's there, not and only representing the commons once, which would be 2 times 2 times 2 times 3, which is 24. And what I figured out is that 24 is my denominator that I want to rewrite these fractions to have. And I do that by multiplying by 1. And when I have these prime factorizations, I'm going like, well, 24 is this, and 8 is 2 times 2 times 2. What's missing is the 3 to make it 24. I don't have to do division and all that kind of stuff. So I realized that to get 8 turned into 24, I need to multiply by 3. Well, the only number I can multiply by that does not change the value of 7/8 is 1. If this denominator needs to be 3, then the numerator has to be 3 too. So I multiply then. Now I just use the rule of multiplication on these two fractions, and I get 7 times 3, which is 21, and 8 times 23 is 24. Hey, I got a fraction that has 24 as a denominator. Now it's not in simplest form, but that's not the point. I don't want to be in simplest form necessarily. I want to get this denominator to be the same for both fractions so I can perform my addition. Well, 12 is 2 times 2 times 3. The only missing factor to make 24 is 2. So I have to take the denominator times 2. So I need to multiply by 1. So the numerator has to be 2, 2. And to say 2, 2, 2 many times. But I get 5 times 2 is 10 over 24. Now I can add. I have exactly the same denominator. I just add the numerators, and I get 31 over 4, and 24, excuse me. And then I need to check to make sure that's in simplest form. In this case, it is. And that's the next examples that they go through. Basically, I'm going to find out what is supposed to be my common denominator, and they also show some things here too. There's usually some new information introduced in our examples, so we'll go through them. This first A is 7/10 minus 1/5. Well, my LCM between 5 and 10 is 10, so I only need to modify one of the fractions. I need to rewrite 1/5 as 2/10. So now I have the same denominator. It's 7 minus 2 all over 10. Well, I can simplify this fraction because there's a common prime number in this case too of 5. So I want to make sure that my resulting of this difference here, or this subtraction, is in simplest form. So I need to then go back to really multiplication of fractions and understand those rules, look for common factors that I can make into fractions equal to 1. If I have 8 times 5/12, right, that's this. Now they're kind of mixing some things here, right? Well, I have 8 times 5/12. That's multiplication of fractions. I can make this be 8 over 1, and I get 8 times 5 over 12. And here they're going to do some things as saying, well, I want my result, or my product in this case, to be in simplest form. Well, I don't want to multiply this and get 40 over 12. I can break this down into prime factors right now. 8 is 2 times 2 times 2, and 5 is prime. And 12 is 2 times 2 times 3. Well, here my prime factors line up, and they're really equal to 1, and they explain that over here. That the reason we can cross those things out is because we can say that we're making those into fractions equal to 1. Now they're starting to introduce this, probably some of the shortcutting that you've been doing when you simplify fractions. You've been probably getting through other math classes with just doing this, not really thinking about this. When you start throwing some variables into these fractions, you're going to have to know what's going on here. So pay attention to the red. But the nice thing about pre-simplifying, basically in a way, is that my resulting multiplication, if I do this, I know is in simplified form, and I don't have to check when I get done. Here's another way to show division. This is 5/6. The whole thing is divided by 25/9. Well, we could write it this way, is where we're used to seeing it. I need to change it to a multiplication by changing the divisor to its reciprocal. And then I can do this pre-simplification. I prime factor stuff, and then I match up common prime factors, and I end up with a result that's in simplest form. There's a technology thing here for graphing calculators we're not using in this class, and then the exercises. So good luck.